If I put in the inverse with tangent, looks pretty, but it's not a function, right? Okay. All that red is a mirror image of all the blue over the line y equals x, but obviously not a function, so we have to restrict the domain of the blue again. Did anybody figure out how to do that? What do you think? Evan?
Negative pi over 2 pi over 2.
Same as for pi, for sine. Let's see. So if we restrict it, negative pi over 2 to pi over 2, it does look like we have a one-to-one function in blue and a function in red. Good. If we go any further, obviously the next section would start populating and then it would fail. Blue would fail the horizontal, the red would fail the vertical. So let's list it out one more time here. If f of x is the tangent of x, and f inverse is the inverse tangent of x, then the domain of the original function is what? Evan?
Negative pi over 2 to pi over 2. Exclusive.
Yeah, it's going to be exclusive this time because of the vertical asymptotes. So it's similar to sine, but it's parentheses instead of brackets. Is that okay with everybody? We're going to see why. As tangent is undefined at those locations. So we've got negative pi over 2 to pi over 2 radians exclusive, or negative 90 to 90 degrees exclusive, or tangent. And we've restricted it that way so that the inverse will be a function. And so the range, what's the range for tangent? It's the range change. Yeah, it's everything, right? So sine and cosine bounce back and forth, but tangent goes up and down to infinity, negative infinity. The domain and range of the inverse, again, will just switch. And so here we'll have a domain of negative infinity to infinity, and a range for the angles from negative pi over 2 to pi over 2 exclusive, or negative 90 to 90 degrees exclusive. I only wrote it down once about the input-output, but that's really important. That applies to all these, right? So when it's the regular trig function, the input is the angle measure, the output is the ratio, and it switches when you're doing inverse trig. So keep that in mind.